A rare visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas,
Astronomers have spotted another mysterious interstellar visitor racing through our solar system, and this one is mind-blowingly huge. Dubbed 3I/A TLAS, it's barreling past at over 150,000 miles per hour and could stretch up to 12 miles across, far dwarfing its predecessor, Oumuamua. Telescopes worldwide are scrambling to study its strange glow, trajectory, and ghostly haze. Some wonder if it's just a frozen rock or something far more extraordinary. Could this colossal traveler from another star hold secrets that redefine all we know? The breaking discovery. Something extraordinary happened in the night skies of late June 2025. Astronomers detected a mysterious object speeding through our solar system at a mind-boggling pace. This wasn't just another space rock or comet. This visitor came from beyond our solar system, making it only the third confirmed interstellar object ever discovered. The object, now officially named 3I/ATLAS, has the entire astronomical community buzzing with excitement. When it first appeared in telescope data, nobody knew exactly what they were looking at. Was it just another asteroid, a comet, or something entirely new? As more observations poured in, one thing became absolutely clear. This object wasn't from around here. What makes this discovery so incredible is how rare these interstellar visitors are. For centuries, we've been scanning the skies, cataloging thousands of asteroids and comets that orbit our sun. But objects from other star systems, those are exceptionally rare finds. Before 2017, we hadn't confirmed a single one. Now with 3I/ATLAS, we've found our third in less than a decade. This isn't just a random space rock passing by, it's a messenger from another star, carrying secrets about distant worlds we may never visit ourselves. The story of how we found it, what it might be, and where it's going next reads like a cosmic detective novel with twists and turns that have astronomers staying up late, glued to their telescopes. As it races through our cosmic neighborhood at an astonishing 152,000 miles per hour, 3I/ATLAS gives us a brief but precious opportunity to study material from beyond our solar system. It's like receiving a package from a place we've never been, a scientific gift delivered across the vast emptiness between stars. The discovery story. The story of 3I/ATLAS began on what seemed like an ordinary night between June 25th and June 29th, 2025. The ATLAS system, which stands for Asteroid Terrestrial Impact Last Alert System, was doing its regular work, automatically scanning the night sky for any objects that might pose a danger to Earth. With powerful telescopes positioned in Hawaii and South Africa, this automated guardian watches over us day and night, looking for the unexpected. And unexpected is exactly what it found. At first, the object appeared as nothing more than a faint dot moving against the backdrop of stars. The system flagged it as interesting, but not necessarily extraordinary, just another space rock to add to the ever-growing catalogue of near-Earth objects. It was initially given the unmemorable designation of 11PL3Z, just a string of characters in the vast database of sky objects. Then came Tuesday, July 1st, when astronomers using a telescope in Chile noticed something strange. The object they spotted wasn't following a normal path. Its trajectory seemed off. It was moving too fast, and its orbit didn't make sense if it belonged to our solar system. Follow-up observations on July 1st and 2nd confirmed these suspicions. This object wasn't circling our sun like everything else in our neighborhood. It was just passing through. The breakthrough came from an unexpected source. An amateur astronomer named Sam Dean decided to look through older images taken by the ATLAS telescope from late June. There it was, the same object captured days earlier, providing crucial data about its path across the sky. This discovery allowed scientists to calculate its trajectory with much greater accuracy. By Wednesday evening, The Minor Planet Center, the official organization that keeps track of objects in our solar system, had received over 100 confirmed sightings from telescopes around the world. Some astronomers even reported signs that it might be a comet, with a faint haze of gas and dust surrounding it. With all this new information, scientists were confident enough to give it a proper name: 3I/ATLAS. The 3I part signifies that it's the third interstellar object ever confirmed, and ATLAS honors the telescope system that first spotted it. Paul Chaz, director of the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, explained that the object is traveling incredibly fast. There's no doubt it came from interstellar space. If you trace its orbit backward, it seems to be coming from the general direction of the galactic center. It definitely came from another solar system, though we don't know which one. The confirmation of a third interstellar visitor in less than a decade has astronomers wondering if these objects are much more common than we previously thought. Perhaps our improved technology is finally allowing us to spot visitors that have been silently passing through our cosmic neighborhood all along. A stranger in our midst. What makes 3I/ATLAS stand out from the countless other objects zooming around our solar system? For starters, it's moving at an absolutely mind-boggling speed of about 152,000 miles per hour. That's fast enough to travel from Earth to the Moon in just over an hour and a half. Most objects in our solar system move much slower because they're bound by the sun's gravity. 3I/ATLAS, on the other hand, is just passing through, barely affected by our star's gravitational pull. Its speed alone tells scientists that this object isn't from around here. When they trace its path backward, it doesn't loop around the sun like comets and asteroids from our solar system do. Instead, its trajectory points toward deep space, suggesting it came from the direction of the galactic center, though its exact star system of origin remains unknown. Then there's its unusual brightness. When Harvard astronomer Avi Loeb analyzed the data, he noticed something remarkable. 3I/ATLAS is reflecting a surprising amount of light for an interstellar object. This could mean one of two things. Either it has a very reflective surface, or it's enormous. If its surface is dark, like most asteroids, 3I/ATLAS would need to be around 12 miles, 20 kilometers, wide to reflect that much light. That's massive compared to our previous interstellar visitors. Oumuamua was estimated to be only about 100 meters long, while Comet Borisov was roughly 400 meters across. If these size estimates hold true, 3I/ATLAS would be dozens of times larger than either of them. Another intriguing aspect is its apparent cometary behavior. Some telescopes have detected a faint coma, a hazy envelope of gas and dust surrounding the object. This suggests it might be a comet, but one quite different from those in our solar system. As it gets closer to the sun and heats up, we might see it develop a more visible tail, which would help scientists understand its composition. Its orbit is also unique. Most objects in our solar system orbit roughly along the same plane. Picture a giant disk with the sun at the center. 3I/ATLAS, however, is plunging through this disk at a steep angle, further confirming it didn't form alongside our planets. The more astronomers observe 3I/ATLAS, the more they realize just how special it is. It's not just another space rock, it's a time capsule from another star system, carrying secrets about distant worlds we've never seen. Every night that telescopes turn toward this visitor, we learn something new about the universe beyond our solar system. The predecessors. To fully appreciate why 3I/ATLAS has astronomers so excited, we need to look at the short but fascinating history of interstellar object discoveries. Before 2017, we had never confirmed a single visitor from beyond our solar system. Not one. For all of human history, we had only observed objects that belonged to our cosmic neighborhood. That all changed on October 19, 2017, when Hawaiian astronomers spotted something unusual using the Pan-STARRS telescope. The object, later named Oumuamua, meaning scout or messenger from afar in Hawaiian, was like nothing we'd ever seen before. Its shape was bizarre, either cigar-like or pancake-flat. Depending on the interpretation, it was tumbling through space, reflecting sunlight in a way that made its brightness vary dramatically. What really puzzled scientists about Oumuamua was its acceleration as it left our solar system. It sped up slightly, which isn't what gravity alone would cause. Normally, objects slow down as they move away from the sun's gravitational pull. This unexpected acceleration sparked intense debate. Some suggested it was outgassing, releasing invisible gas that acted like a subtle rocket engine. Others, including Harvard's Avi Loeb, proposed more exotic explanations, including the possibility that it might be an alien light sail or spacecraft. Oumuamua left our solar system quickly before we could get a good look at it with our most powerful telescopes. It left behind far more questions than answers. Then came our second interstellar visitor, discovered in August 2019 by amateur astronomer Gennady Borisov. Unlike the mysterious Oumuamua, this object, named Comet 2 I/Borisov in his honor, was unmistakably a comet. It had a visible tail and behaved much like the comets in our own solar system. Borisov was easier to study because it was spotted months before its closest approach to the Sun. Scientists determined it was about 400 meters across and composed of materials similar to those found in comets from our outer solar system. This similarity was intriguing. It suggested that perhaps comet formation is similar across different star systems. These two visitors were tantalizing glimpses of objects from beyond our solar system, but their differences raised many questions. Oumuamua didn't look or act like anything we'd seen before, while Borisov seemed remarkably familiar. Now, with 3I/ATLAS, we have a third data point that might help us understand what's normal and what's unusual about these cosmic wanderers. The rapid succession of these discoveries, 3 in less than a decade after centuries of seeing none, has made scientists wonder if interstellar objects are actually much more common than we thought. Perhaps they've been passing through all along, and we simply lacked the technology to detect them until recently. The cosmic journey. Let's follow 3I/ATLAS on its remarkable journey through our solar system. Right now, in early July 2025, it's zooming through space at over 152,000 miles per hour, currently positioned about 3.8 times farther from the Sun than Earth is. That's beyond the orbit of Mars, but well within the asteroid belt. Unlike objects that belong to our solar system, 3I/ATLAS isn't circling the Sun. It's on what astronomers call a hyperbolic trajectory, essentially a one-way path that will take it through our solar system and then back out into interstellar space, never to return. If we could trace its path backward through space and time, it would lead us toward the center of the Milky Way galaxy. However, pinpointing its exact star of origin is practically impossible. Space is vast, and during the millions of years it might have traveled, stars themselves have moved. It's like trying to figure out which raindrop came from which cloud. The connections have been lost to time and distance. Looking ahead, 3I/ATLAS has some interesting encounters on its schedule. On October 3rd, 2025, it will make its closest approach to Mars. This will be the first time it passes near one of our planets, giving astronomers a chance to measure how the planet's gravity might slightly alter its path. Then, on October 23rd, 2025, 3I/ATLAS will reach perihelion, its closest point to the Sun. Even at this nearest approach, it will still be about twice as far from the Sun as Earth is. This distance is important for a few reasons. First, it means the object won't get intensely heated by the Sun, which could have caused it to break apart if it's a fragile comet. Second, It ensures that 3I/ATLAS poses absolutely no threat to Earth. Speaking of Earth, our planet will be on the opposite side of the Sun when 3I/ATLAS reaches its perihelion. The closest it will come to us is in December 2025, and even then, at a very safe distance. After that encounter, it will begin its long journey back into interstellar space, gradually picking up speed as it escapes the Sun's gravitational influence. What's fascinating about this journey is that 3I/ATLAS is essentially a tourist in our solar system, a brief visitor passing through on its eternal voyage through the galaxy. It formed around another star, perhaps billions of years ago, and has likely been traveling through the empty void of interstellar space for millions of years before chancing upon our cosmic neighborhood. And just as it arrived unannounced, it will leave again, continuing its journey to who knows where, carrying with it a brief history of its encounter with our sun and planets. A history that will never be read by anyone unless it happens to pass through another star system with intelligent beings capable of detecting it. A scientific goldmine. The discovery of 3I/ATLAS isn't just an astronomical curiosity, it's a scientific goldmine that could revolutionize our understanding of how planetary systems form throughout the galaxy. Think about it. Until recently, the only planetary system we could study up close was our own. Everything we know about planet formation, asteroid composition, and cometary behavior came from objects that formed around our Sun. Now, with 3I/ATLAS, we have a genuine piece of another star system passing right through our cosmic backyard. It's like being able to pick up and examine a rock from Mars without having to send a rover there, an opportunity to study material that formed under completely different conditions than those in our early solar system. What makes this opportunity even more valuable is that 3I/ATLAS appears to be much larger than our previous interstellar visitors. Its size means we can get better observations, more detailed spectra, and potentially even determine its composition with greater accuracy than was possible with Oumuamua or Borisov. If 3I/ATLAS is indeed a comet, as some early observations suggest, it offers us a chance to compare its ice, dust, and gas content with comets from our own system. Are the same chemicals present? Are they in similar proportions? The answers could tell us if the ingredients for life as we know it are common throughout the galaxy or unique to our corner of space. Another exciting aspect is that we're catching this object relatively early in its journey through our system. Unlike Oumuamua, which was already on its way out when discovered, we'll have months to study 3I/ATLAS as it approaches the Sun, reaches perihelion, and then departs. This gives astronomers time to coordinate observations using different telescopes and instruments around the world and in space. The timing couldn't be better from a technological standpoint either. When Oumuamua passed through in 2017, the James Webb Space Telescope wasn't yet launched. Now, with Webb fully operational, along with other advanced observatories, we have unprecedented capabilities to study this interstellar visitor in detail. Perhaps most importantly, each new interstellar object we discover helps us answer a fundamental question. How common are these visitors? Before Oumuamua, some scientists estimated we might see an interstellar object once every few decades. Now, with 3 confirmed in less than a decade, those estimates are being dramatically revised. It seems likely that interstellar objects pass through our solar system much more frequently than we thought, perhaps multiple times per year, with most going undetected because they're too small or too distant from Earth. If interstellar objects are indeed common, it suggests that planetary systems throughout the galaxy routinely eject material into interstellar space. This in turn tells us something about how planetary systems evolve and interact with each other across vast distances and time scales. Unanswered questions. Despite all our advanced technology and brilliant scientists, 3I/ATLAS guards many secrets that leave astronomers scratching their heads. One of the biggest mysteries is its exact nature. Is it a comet, an asteroid, or something we don't have a category for yet? Early observations show hints of cometary activity, a faint fuzzy appearance that suggests gas and dust might be escaping from its surface as it's warmed by the sun, but it doesn't yet have the dramatic tail we associate with comets. Some astronomers think it might be what they call a pristine comet, one that has never passed close to a star before and still has its original ice intact. Then there's the puzzle of its unusual brightness. As Harvard astronomer Avi Loeb pointed out, 3I/ATLAS is reflecting more light than expected. If it has a dark surface like most asteroids, it would need to be enormous, around 12 miles across, to appear this bright. But if its surface is highly reflective, it might be much smaller. Determining its actual size and reflectivity is proving challenging even with our best telescopes. Another mystery is its rotation. Most space objects spin as they travel, but measuring the rotation rate of 3I/ATLAS has been difficult. Some observations suggest it might be tumbling chaotically rather than spinning smoothly on a single axis. If true, this could indicate that it experienced some violent event in its past, perhaps a collision with another object or a close encounter with a massive body that disrupted its rotation. There's also the question of its age and origin. Did it form recently around a nearby star, or has it been wandering the galaxy for billions of years? The surface features and composition might hold clues, but getting that level of detail requires observations we haven't yet been able to make. Perhaps the most tantalizing mystery is what 3I/ATLAS might tell us about the system it came from. Every star system leaves its fingerprint on the objects that form within it. Particular ratios of elements, specific minerals, unique isotopic composition. If we can decode these fingerprints, we might learn about a planetary system we can never visit directly. Some astronomers are also watching carefully for any signs of non-gravitational acceleration as 3I/ATLAS travels through our system. Oumuamua showed such acceleration, which sparked considerable debate. If 3I/ATLAS also accelerates in ways that can't be explained by gravity alone, it would suggest that this might be a common feature of interstellar objects, rather than something unique to Oumuamua. These mysteries make 3I/ATLAS more than just another object to catalog. It's a cosmic puzzle box, with each new observation potentially unlocking another clue about its nature and history. And with several months of observation ahead before it leaves our solar system for good, astronomers are hoping to solve at least some of these puzzles before saying goodbye to our interstellar visitor, the alien question. When talking about objects from beyond our solar system, there's always the tantalizing question that captures public imagination. Could it be artificial? Could we be observing something made by intelligent beings from another star system? This question isn't just science fiction speculation. Harvard astronomer Avi Loeb, one of the most respected astrophysicists in the world, has been vocal about considering this possibility, especially after the puzzling observations of Oumuamua in 2017. Loeb famously suggested that Oumuamua might have been an alien light sail or probe based on its unusual acceleration and strange shape. With 3I/ATLAS, Loeb has once again entered the conversation, suggesting that scientists should use the powerful James Webb Space Telescope to look for signs of non-gravitational acceleration, movement that can't be explained by gravity alone. If such force is detected, it could potentially hint at some kind of artificial propulsion. Before getting too excited about alien spacecraft, it's important to understand that non-gravitational acceleration can have natural explanations too. Comets often show this behavior as ice on their surface turns directly into gas when heated by the sun, creating a gentle thrust like a tiny rocket engine. This outgassing can subtly change a comet's trajectory in ways that pure gravitational calculations don't predict. What would make 3I/ATLAS truly suspicious from an artificial standpoint? Several things could raise eyebrows among scientists. If it changes direction in ways that defy physics, if it emits radio signals or shows other signs of technology, or if its composition includes elements or isotopes in combinations that can't form naturally, these would all be red flags that something unusual is going on. Another thing astronomers are watching for is whether 3I/ATLAS maintains a constant brightness or shows regular patterns in its light reflection. Natural objects tend to be irregular in shape, creating variable brightness as they rotate. A more consistent brightness could suggest a more regular, potentially artificial shape. The reality is that while considering artificial origins is scientifically valid, the history of astronomy teaches us that natural explanations usually win out. When pulsars were first discovered in the 1960s, their incredibly regular radio pulses led some scientists to briefly consider them as potential alien beacons. We now know they're rapidly rotating neutron stars, exotic but entirely natural objects. Still, the possibility, however remote, that we might be observing technology from another civilization is part of what makes these interstellar objects so captivating to both scientists and the public. It forces us to consider the ultimate question: are we alone in the universe? Even if 3I/ATLAS turns out to be a perfectly natural comet or asteroid, the very act of investigating all possibilities, including artificial origins, advances our scientific understanding. As Carl Sagan famously noted, extraordinary claims require extraordinary evidence. While most astronomers consider it highly unlikely that 3I/ATLAS is artificial, they'll certainly be looking for any extraordinary evidence that might suggest otherwise as it makes its journey through our solar system. Observing the visitor. How exactly do you study a dark object potentially smaller than a city, moving at 152,000 miles per hour, billions of miles away? It takes some serious technological firepower, and fortunately, we have more of that now than ever before. Right now, astronomers around the world are pointing every available telescope at 3I/ATLAS, creating a global effort to understand this visitor before it leaves our neighborhood forever. Ground-based observatories from Hawaii to Chile to South Africa are tracking its movement, measuring its brightness, and analyzing the faint light it reflects for clues about its composition. But the real game changers are our space-based observatories. The James Webb Space Telescope, with its massive 21.3-foot mirror and incredible infrared sensitivity, is perfectly suited for studying objects like 3I/ATLAS. Webb can detect heat signatures and identify specific chemicals and minerals on the object's surface. Astronomers have already secured valuable observation time on Webb to study this interstellar visitor in detail. Hubble, despite being older technology, still provides invaluable data too. Its ultraviolet capabilities complement Webb's infrared strengths, giving astronomers a more complete picture across different wavelengths of light. Together, these space telescopes can reveal details about 3I/ATLAS that would be impossible to see from Earth's surface. Beyond just looking at it, astronomers are also listening. Radio telescopes, like the Very Large Array in New Mexico and the Allen Telescope Array in California, are monitoring for any unusual radio emissions. While no one seriously expects to pick up alien broadcasts, these observations can help determine if the object is giving off any radio waves as it interacts with the solar wind, the stream of particles constantly flowing from the sun. As 3I/ATLAS gets closer to the sun, we'll see it more clearly. Its brightness will increase, and if it is indeed a comet, we might see a more pronounced tail develop. This would give scientists even more material to study, as the tail contains particles and gases released from the object itself. Dawn of a new era. The discovery of 3I/ATLAS marks what many astronomers believe is the beginning of a new era in our understanding of interstellar objects. For all of human history, until 2017, we had never confirmed a single visitor from beyond our solar system. Now we've found 3 in less than a decade. This isn't just coincidence. It's the result of technological advancement. Our ability to detect these cosmic travelers has improved dramatically in recent years. Automated sky surveys, more powerful telescopes, and sophisticated software that can identify unusual movement patterns have all contributed to this revolution. What we're seeing now isn't necessarily a sudden increase in interstellar visitors. Rather, we're finally developing the eyes to see what was always there. The Vera Rubin Observatory, when it begins operations, will take this capability to an entirely new level. Its enormous camera will photograph the entire visible sky every few nights, creating a movie of the cosmos that will make it much easier to spot moving objects. Astronomers predict it might discover several interstellar objects every year, perhaps dozens. This growing catalogue of interstellar visitors will allow scientists to answer questions they could only guess at before. Are most interstellar objects comets, asteroids, or something else entirely? Do they typically come from the inner or outer regions of their home systems? How often are planetary systems ejecting material into interstellar space? The answers will reshape our understanding of how planetary systems form and evolve. There's also growing interest in the possibility of sending a spacecraft to intercept an interstellar object. While 3I/ATLAS was discovered too late for us to launch such a mission, several space agencies and private companies are developing concepts for rapid response spacecraft that could be launched on short notice if another interstellar object is detected early enough. Beyond the pure science, these discoveries are changing how we think about our place in the cosmos. Each interstellar object is a physical connection to another star system, tangible evidence that the space between stars isn't empty but is crisscrossed by material ejected from other worlds. In a very real sense, our solar system isn't isolated but is part of a larger galactic ecosystem where material from one star system can eventually become part of another. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.